Hello everyone, and thank you for joining us on our first online tech meetup. Our first offline tech meetup occurred back in 2015, and with the years, it became one of our favorite traditions. As you know, we are now practicing physical distancing, so we decided to host our first online tech meetup. But what are the trending topics that are evolving around technology this year? Artificial intelligence, machine learning, and digital transformation are definitely buzzing all over the tech world. In that manner, we decided to cover all of those topics on today's webinar. So the presenters for today, in order of speaking, are Petar Rajchinoski, Aleksandra Stojanovski, Marjan Sterjev, and Cvetanka Eftimoska. Without further ado, let's start the webinar, and I hope you will all enjoy the topics we have prepared for you. First in line, as I mentioned, is Petar Rajchinoski. He has been part of Interworks for 3 years now as part of our SnapLogic practice. And today he will talk about SnapLogic and recognizing emotions in IMDB comments using SnapLogic machine learning. Petar, take the lead.
Thank you, Renata. Hi, everyone. I'm glad I'm here today, and I hope we'll have a quality time exploring and learning new things. So let me share my screen first. And we can start. So in the next 15 minutes, I will talk about SnapLogic and where can we use SnapLogic as an integration tool. I will cover the data science in SnapLogic with a simple IMDB comment evaluation demo. So let's first see what is SnapLogic and where can we use SnapLogic as an integration tool. So we usually describe SnapLogic as an intelligent integration platform that is AI powered, integrates and can help companies to integrate data from many sources and in any environment at any speed. For that purpose, we have more than 500 predefined connectors, which are called snaps, and they can connect your data and application from various sources on cloud and on-premise as well. So let's see where can we use SnapLogic as integration platform. So we have application and data integration, and for in this field we can, as I previously said, we can connect or integrate each application and data source like database files and etc. So we can make more systems working like one and sharing data in between. So once we have some process in SnapLogic that is developed and is ready to be deployed and exposed as REST API, we have API management within SnapLogic, which is really easy to expose, consume, and maintain the APIs in SnapLogic. And also we have clients that are interested in B2B integrations, and we can modernize their EDI systems with unified cloud-based solutions as well. The last but not the least is in the list is data science, and this topic will be the one that I'm gonna put more attention on the demo today. So let's see why SnapLogic data science. And we know that machine learning is a popular and trending topic, and it is really useful, but can be tricky to build even a simple machine learning project if you are not data science expert. And as Renata said, I'm expert in integration field, and I was always interested in what can be done in SnapLogic using the SnapLogic machine learning snap packs that are predefined and that pulled me to investigate and see the capabilities of SnapLogic as a data science tool. So why SnapLogic? Because we know that a lot of projects, machine learning projects and natural language projects are written into Python, for example, like a programming language. But SnapLogic is providing actually virtual drag and drop approach, and also we have predefined snaps or connectors that are for data preparation and exploration, as well as training and validation snaps. And once everything is done, we can go and deploy the model and also monitor the model and the process through the dashboard that SnapLogic is providing. So let's see what we have in the next flow chart. We have the full path of every machine learning project, starting from data collection through data preparation, model training and validation, and at the end model deployment. So in data collection step as the first one, I pulled I was looking for some data that can be used for my demo, and I found that there's the IMDB data collection with positive and negative comments, and that are appropriately classified stars. Machine learning, data preparation, snap learning analytics, SnapPack, that can actually help us doing the machine learning project. So in this step, we are cleaning the missing values, refining the data, and then we're passing the data through model training and validation using the machine learning core SnapPacks. In these SnapPacks, we have a classification and regression trainer, cross validators and predictors. Also, we have a remote Python script, which will allow you to write native Python code in SnapLogic and integrate it with Jupyter Notebook, if you are familiar with writing Python as well. So in these two steps, we can see that we have almost 20 snaps that are specifically built for machine learning in SnapLogic and can help every developer to make his machine learning project work. So the final step in our situation will be the model deployment, and actually I will expose the process as a REST API. So let's first find out what we have here. We have one test and we have one train folder, and in the train folder we have positive and negative comments. We have a lot of comments, nearly even above 20,000 of them, and they are classified with the stars. So the second number of the file name is the star number, and here we have content of the appropriate comment. So let's go into SnapLogic. So we have SnapLogic is cloud-based, and we don't we can work from anywhere. Actually, we'll need just login credentials to log in to our SnapLogic account, and once we're here, we can see the designer, manager, and the dashboard tabs that are the three main tabs that we will be working on, and actually in the Snap, we have group by SnapPacks, and if we search for the machine learning SnapPacks, there will be machine learning analytics, machine learning core, data preparation, and the last is natural language processing snapback, which will be used for this demonstration as well. So let's see what we have on the initial pipeline that we have. We have the train zip or train archive file, and when we validate it, we get the content, actually the comment of the file as a text field, and the second number of the name of the file is pulled as a star. So once it is validated, we have written to the JSON file that is called IMDB underscore train dataset.json. So this file will be passed, will be in data preparation pipeline. So here we have a data preparation pipeline, and the main goal of this pipeline is reading the train dataset that we have and writing it writing IMDB process .json file that is output of the bag of words snap, and then we have another output file of this process that is IMDB underscore comma underscore words.json. So let's see what this process has. So once we read the file, we have snaps that are used for sampling in data preparation. And for this particular case, I use stratified sampling, and that will give me appropriate, actually equal number of comments for each star. It will make a distribution for equal chunks of data. Then it will be passed to the tokenizer snap, which is the second snap from the machine learning snap packs that they're used in this process. And this snap will get the input data, actually the input string, and then we'll just make it as a list of tokens. So the output of the tokenizer snap will be a list of tokens. Here we have what that might look like. So once we have the tokenizer, one copy of the tokenizer snap is going directly into the bag of words snap, actually on its left input, and second output, second copy is going into the common word snap, which will give us the list of most common words that are occurring in the input of the common word snap, actually in this data set that we are sending to the common word snap. So once that is done, we are writing one copy with that common words data, and second input is actually output is going into the bag of word snap on its right input, and then the output is written into the file that we previously mentioned, that is IMDB underscore proceed.json. So this is a simple data preparation step, but sometimes we have a lot of snap that can be used depending on what the goal should be, but the goal must be to get the cleanest in and data set possible for training. So we have datetime extractors, match, and a lot of type converter also, and other stuff that can help us cleaning and refining the data set that we have on the input. So before we move to the train process, we need to decide what will be the appropriate algorithm that will be used for training the model. And in SnapLogic we have currently 8 algorithms. that can be used in training and testing the model. So for the purpose of choosing the best one, we are using cross-validator classification snap, which will give us the best accuracy of all algorithms regarding to the input dataset. So the input dataset will be IMDB underscore process. So the one that we provided after the bag of words snap will be the input into the cross-validator snap, and the output will be file that can be actually that will point us to the algorithm that has the best accuracy for the appropriate input dataset. So we can see that in this particular case, logistic regression has best results, has the best precision, and we choose the appropriate algorithm, and then we're going to train the model. So what we have to train the model, we need to use trainer classification snap. So because we are doing classification whether the comment is positive or negative, then we are using trainer classification snap. Also we have a regression snap. So the input is the IMDB process, the JSON, and we have algorithm as logistic regression because we saw that it is the best one that will provide the best precision in this case, and it also has some options that can be applied, some settings that can be set, but let it as default. And the model is written to the JSON file that is called IMDB underscore model.json. So once we validate the file, we execute it. We execute the process. Then we have model in a JSON format. And the last thing of the chart that we previously saw was exposing the process as a REST API, or actually deploying the model. So we have a model, we have a common words file that was created previously in the first step, and all of them will be used into the final process that will be exposed as a REST API. So the REST API process or the API will be a process that will have open input that should receive some text, and once it receive the comment, it will go through the tokenizer snap, create a list of tokens for the input comment, and using a bag of words and the common words that are connected into the right input of bag of words, it will pass it through the predictor classification snap. So in this predictor classification snap, we need to choose the maximum output, and we are specifying that should be one prediction, and we can choose whether it to display or not the confidence level of the prediction that is made. So once we have the predictor set up properly on its right input, we'll just pass the model into the JSON from the JSON file that we previously created in training the model, and then output the appropriate prediction of that will return the predictor classification snap. So it's that simple to create a API. So this will be exposed creating a task. So once the task is created, we can use a bearer token, and then go into the Postman, set up properly, or whatever REST client that you might use, our application. Then, for example, search for some IMDB comment. Let's find some film, let's say Joker, and search for the reviews just to test it, the process. Let's find some really bad. Okay, I feel everyone is brainwashed. Let's see if predictor has the same meaning. So once passed to the prediction that the string or the comment that is passed might be negative, and the prediction precision is basically near 0.8. So we can also monitor the process in SnapLogic and see that everything is fine. You can go into the dashboard and see the process that is completed. So this is how can we shortly create some simple machine learning, actually natural language processing project in SnapLogic, and how can SnapLogic help everyone reach the machine learning. Thank you for your time and patience. So we can continue with our next call.
Thank you, Peter. Thank you for the wonderful presentation. Just to point out that you can ask all of your questions after the presenters have finished presenting at the end of the webinar in the question and answers tab or by raising your hand. So our second presenter is Aleksandra Stojanovski, and her presentation is related to robotic process automation in selected business cases. Aleksandra has been part of Interworks for 6 years now, and she is part of our quality assurance team. Aleksandra, go ahead.
Thank you, Renata. In these 15 to 20 minutes, I will talk about robotic process automation. As well, I will present some business cases that we have solved using RPA. So in this presentation, as introduction, I'll talk about what is RPA and benefits of using RPA. And then I'll present two interesting business cases, or let's say processes, that we have implemented with UiPath. So what is a robotic process automation? If I have to elaborate on each of these terms one by one, then robotic refers to entities that mimic human actions that are called robots. Process is a sequence of steps that leading to meaningful activity. And automation is any process that is done by a robot without any human intervention. So when we summarize all these terms together, then mimicking human actions to perform a sequence of steps that leads to meaningful activity without any human intervention is known as robotic process automation. Basically, RPA robots logs into applications, moves files and folders, copy and paste data, fill in forms, extracts data, scrape browsers, and more. What distinguishes RPA from other traditional IT automation is the ability of the RPA software to be aware and adapt to changing circumstances, exceptions, and situations. Once RPA software has been trained to capture and interpret the actions of specific processes in existing application, it can then manipulate data, trigger responses, initiate new actions, and communicate with other systems also. Why RPA? There are many reasons why to implement RPA and what are the values that it can bring. First, released value means that RPA relieves humans of repetitive, boring tasks. and it's allowing them to focus on more intellectually valuable activities and demand human creativity. Reduced error rate means that RPA doesn't get bored, tired, or distracted. Error rates come down, which means less rework. RPA saves money. The reports are telling that RPA is typically 30 to 60% cheaper than onshore workers and 10 to 30% of offshore. RPA is doing more for less, so it can process much greater volumes of work at a much higher speed than a human. RPA is fast, so no need for large-scale system integration. RPA can be implemented without re-engineering business processes, without disturbing existing systems and applications, so that major productivity improvements can therefore be achieved quickly and, most important, cost effectively. And the last benefit of RPA is that it's auditable and secure. And that means that robots will only ever access what you tell them to, and will create a detailed audit trail of all activity. Let's now move on one of the business cases related with invoice processing that we have solved with UiPath. So invoices are coming as attachments in PDF format. Usually an employee should manually open the mail, get PDF attachments, and then again manually enter relevant invoice information into, for example, some Excel spreadsheet or some other system. So the relevant data from the PDF invoices should be extracted in a format that further can be easily processed. Using RPA, all steps of this process can be automatically done by a robot without any human intervention. So in particular, at high level, it looks like it's displayed in this picture. So robot will get relevant emails, for example, emails with specific subject, or it can be specific sender. Then it will download the invoices in particular folder, and further it will intelligently discover and extract the relevant data, the relevant invoice information into some Excel spreadsheet. It can extract to, it gets saved to database, some applications, or even it can execute the REST API calls. So next, I'll show you a short video about how UiPath robot implementation looks like, and we will also see the robot in action. So these are the PDF invoices from which the robot will have to extract some relevant data like address, city, state, bill to, invoice number, item description also, and total. The invoices will be sent to email with specific subject. In this case, the subject will be invoice. So this is how robot implementation looks like in UiPath. The first sequence is going to download the invoices from email. So basically this sequence is going to iterate through each email message in the specified account where the subject is invoice. And once such email is found, it will download the email attachment into specific location. In the second sequence is happening the data extraction. This time the robot will go through each downloaded invoice, and by using Visual Basic Expression, it will extract the relevant data like invoice number, invoice date, bill to, address, state, city, and so on. The extracted data will be saved into an Excel spreadsheet. That is happening right here. And once the invoice is processed, it will be moved into separate location, separate folder for processed invoices. So let's see how this robot looks in action. As you can see, the robot did the job in a record time, much more faster than doing the same thing manually. So if we open the spreadsheet, we can see the extracted data for each invoice. So we have invoice number, invoice date, bill to, address, city, state, zip code, total, and description extracted in a record time. Another business case that can be easily automated with RPA is as follows. Consider that multiple sales representatives gather leads info into an Excel spreadsheet, and further that info should be entered into Salesforce. Usually that will be a manual process where Salesforce representative will need to enter leads information into Salesforce manually. So, however, all this manual process can be easily transformed into a robot that will execute the manual work for entering data into Salesforce. The RPA solution that we have developed, again using UiPath, is looking as follows. So the robot will get Excel files with lead info, then we'll process that files by using API and we'll create leads in Salesforce. And finally, because we want to be sure that leads are created, the robot can perform validation if the created lead data is according to the input CSV files. And this will be done in my case by calling expose Salesforce API, or otherwise it can be done directly on the Salesforce UI. Also, I want to mention that this solution is available for free on UiPath Marketplace from the link displayed below. You can download it if you're interested for free. So let's see how this robot looks like. As I said, this robot will read predefined data from multiple CSV files and will use that data to create leads. So in this case, I have two CSV files with lead data. This is the first one. And here I have data for creation of only one lead. And here we have the second one. And in this CSV file, I have data for creation of 2 leads. So this means that 3 leads in total should be created in Salesforce. This is the robot implementation is UiPath. The first sequence of the robot will ask the user to populate Salesforce credentials as well as location of the CSV files where we have the data for leads creation. The second sequence at first will check if CSV files exist in the specified location, and if there are CSV files, it will iterate through each file and read the file and put the output into a data table that later will be used for leads creation. Next, the robot will check if all required parameters are populated in the CSV file. If that's not the case, it will display a message box for missing required fields. And next, by using @lead activity, it will try to create the leads into Salesforce. Some exception handling is also implemented in this robot. So the robot will catch the exception that will happen in case if invalid Salesforce credentials are populated, or if we try to create duplicate leads that are already created. And at the end, the robot will perform validation for the created leads for each field that has been populated. So let's see this robot in action also. In the following input dialogues, the user will have to populate Salesforce credentials as well as a location of the CSV file so that robot can connect to the Salesforce. And now the robot is processing. And again, the robot did the job in the record time. If we check directly on the Salesforce UI, we can see that we have the 3 leads created. So automation is going to be the future of business industries. The automation has changed the world completely and it will continue doing so as it made our life very easy. RPA implementation in organizations enables effective redeployment of employees to much more value-added roles. This in turn increases employees and customer satisfaction. And to sum up, the advantages offered by RPA cannot be ignored, and its application must be considered in many different industries. So thank you very much for your attention.
Thank you, Aleksandra. Great presentation. Next in line is our Chief Technology Officer, Marjan Sterjev. And as an expert in the field of technology with more than 20 years of experience in IT, he will talk more about digital transformation, collect, transform, understand, and utilize your data. Go ahead.
Thank you, Renata. Let's start the presentation. Okay, let's go back to the data and information. Who owns the data and the information owns the world. Information and data is a weapon. It has been classified as a weapon, at least. So, if it is that important, we must understand what data is and what kind of data types we have. We have traditional structured data stored in databases. We have semi-structured data stored in files like JSON files, comma-separated values, etc. And most importantly today, we have totally unstructured data like server logs, audit logs, email messages, audio call recordings, images, video, etc. I must stress that unstructured data is the most has a great value and impact today, because most of the value we generate today through social networks and other online services is unstructured data. It is not generated through integration with APIs, databases, etc., etc. It's just clean text, video, or audio. So we must store this disparate data somewhere. What kind of destinations we have in enterprises and companies that want to have some value from that data? One destination could be data warehouse. Another destination could be Elasticsearch. Another, which is typical for unstructured data, is data lake like Hadoop HDFS, Amazon S3, Azure Block Storage, etc. So it is very important, once you know what kind of data you have, to select your source data, filter that data, transform that data into appropriate format, enrich and save it into the final destination. What kind of tools we have today for this extract, transform, load, or the so-called ETL processes? We can create ETL processes with tools like SnapLogic, MuleSoft, TIBCO, SQL Server integration services, Pentaho ETL, and other commercial and open source tools. Apache Spark for batch and stream processing. We have some tools related to Elasticsearch like Bits, Logstash, Fluentd, Apache Flume. We have data streaming processing engines like Kafka, Amazon Kinesis, and some tools and products above Amazon Kinesis, like Amazon Kinesis Firehorse for collection and storage into various AWS destinations like S3, Elasticsearch, Redshift, and Splunk. So a typical workflow of some ETL process could be the one we have on this image. For example, SnapLogic periodically polls the source database, pickups the records, and transforms these records by normalizing the records, filtering the records, enriching those records, and finally storing those records into data warehouse. After that, we can have standard business intelligence processes for slicing and dicing that data. But the question is, if we have this periodic scheduled process for pulling data based on some update timestamps on incremented primary keys, can we do that in real time? And the answer is yes. Kafka is a very rich ecosystem. So there is a product called Kafka Debezium connector that can read continuously through the database write-ahead logs. A process called change data capture process or CDC. And after that, the events are stored into Kafka topic for further processing, alerting or storage. Besides Kafka Debezium connector for a real-time pickup of these change data records, we have also commercial tools related to Oracle, for example, Oracle Golden Gate, that will do the similar thing. It will pick up the changes from the write-ahead log and publish those changes into Kafka for further processing. So very powerful mechanism for collecting data. Once we have the data, the question is, what are we going to do with the data? Where is the data stored? For example, in the enterprise, do we have catalogs for database storage in the enterprise? Is the same way we can ask ourselves, is that data classified? For example, does it contain personally identifiable information? For example, if we are dealing, or the company deals with only financial transaction processing and credit cards, probably they have personally identifiable information, and that information must be classified and protected appropriately. After that, once we have the data catalog and we know what kind of data and where it is stored into the enterprise, we must know who has access to that data. Not everyone has to have data to especially for personally identifiable information. So we constantly must monitor when the data is created or changed. Once we have monitoring process for that data, we must find suspicious events for data access. Thus, anybody accessing data has a right to see that data or manipulate the data. So how can we accomplish this monitoring process and detecting process for anomalies and outliers based on some techniques and technologies like machine learning, regular expression, etc. I have an example here. For example, we can continuously monitor your file servers, detect file changes, and evaluate the content of that file. It is very important to evaluate that content of file. We must create alerting and decision and notification based on the file content. And if we find something that was created or changed, we have classified that file as very sensitive, and the place where that file is stored is not appropriate. It is not to be stored on that place, then we must raise an alert. This is a common problem across the enterprises, so we can implement this monitoring and security alerting using open source solution architecture, but also we have cloud-based commercial solutions. So if we use open source solution architecture, we can use the ecosystem beside Elasticsearch that is very rich ecosystem. So we have the so-called file integrity module that monitors the files. It will detect file creation and file changes. After that, once the change is detected, file metadata is streamed into Logstash, which is collector. On the previous slide, we mentioned Logstash as a collector of data into Elasticsearch ecosystem. And Logstash destination will evaluate the file. It will read the content of the file, and based of previously training the machine learning model, for example, FastText is an excellent tool which can be used as command line tool, but also as Python API and library. Spicy, natural language processing library that will help us detect named entities like name of people, cities, religious orientation, rule engines, and finally, good old regular expressions. Even if we do all this machine learning stuff, finally with regular expressions, we can detect credit card formats stored into that file. And once we have something classified as sensitive, we can raise alert if it is not stored appropriately. As a cloud solution, we have Amazon Messi. This is not the name of the famous football player. On the contrary, this is a cloud service, AWS cloud service, that can automatically detect once the files are stored in Amazon S3 buckets. And it is using extensively machine learning and some other techniques like regular expressions. I must to mention that Amazon Messi at the moment is still optimized for English language only, but I suppose in the period to come, it will optimize for other European or world languages, but it exists and it is very efficient in this classification of the information. So another example regarding security risk and compliance regarding the data with own is continuously monitoring our web server traffic logs. For example, let's suppose we have an API and web application dealing with financial transactions. So what we can implement using machine learning and detect some suspicious events. For example, in the log event, especially the programmers and developers know that Apache log format contains information about the API and second about the URL. Once we have that information, we can train and build machine learning if some access from some IP address, probably located into the center of the Caribbean tree, makes some financial transactions. So on the following diagram, we can see the flow of this anomaly and IP outlier detection. We have web log. After that, file bit, which is again Elasticsearch module in the Elasticsearch ecosystem, will read line by line in the log file and publish those lines to the Logstash. Logstash will have a destination that will predict if that line based on the URL and the IP address contains suspicious IP address. What can we use for suspicious IP address detections? Basically, AWS SageMaker has already to use production-ready algorithm called IP Insights. And this IP Insights algorithm is not based just on static mapping between IP addresses and sensitive URLs. Rather, this IP Insights algorithm will learn in time continuously what normal is. So at the beginning, we have cold start, everything looks normal, but in time, after a couple of days, the system will know if some IP address is really suspicious, and submitting financial transactions from suspicious addresses and suspicious locations is very important today, because there is a lot of fraud activity, especially in the banking sector. So another thing we can do with data, what we have is predict your customer behavior, or something known as know your customer. So what we have, once some enterprise and company builds an application that interacts with a customer, we have their basic info like age, education, marital status, job, but also we have information how we interact with those customers. Were they involved in some campaigns, the outcome of those campaigns, number of calls our agents made to particular customer, did he or she agree to something or not? So we have a lot of data. we can use this data in order to make some decisions. For example, will particular customer deposit something or not? Predict churn, or is the customer going to stop using our services or not? Product recommendation, etc. The first problem about predicting something like placing a deposit or not, churn from our services or not, is just a classification problem. And today we have plenty of algorithms we can use for classification. I would mention here logistic regression, we have deep learning, fast forward networks, and especially I would like to stress the XGBoost algorithm that behaves and performs pretty well on the Kaggle competition in the last couple of years. So I would definitely say, if you are in doubt what algorithm to use for classification purposes, try the XGBoost algorithm. Another thing we can try based on data we have about our customer, yes, we know our customer, is collaborative filtering or product recommendation. This is a very simple model. It exists for a long time. It is the same product recommendation mechanism we see when we buy books on Amazon, when we watch movies on Netflix. And basically everything started with Netflix, which was organizing each year a competition about best product recommendation algorithm. So in essence, we have two-dimensional metrics with product recommendation. On the row axis, we have customers. On the column axis, we have the products. And we have axis if customer 1 has been using product 1, and product 3, customer 3 has been using in the past product 1 and product 4. So based on this common information, we can offer product recommendation to customer 2, like offering him product 2 or product 3. What kind of algorithms we can use for product recommendation and collaborative filtering? Two of the best known algorithms is alternating least squares, and it has been implemented in Apache Spark machine learning as a distributed algorithm for product recommendations. But also we have factorization machines, which is very suitable when we have cold start. For example, starting with empty set of customers. This is very powerful algorithm because it will take into account some customer attributes like age, education, marital status, etc., besides the products he was dealing with. So when we talk about product recommendation, especially AWS, I would recommend trying factorization machines on AWS, which is also SageMaker out-of-the-box production-ready algorithm. Another use case, once we have data about our customers, especially when we deal with banking transactions, is fraud transaction detection. Again, what we have for our customers, we have their basic info like age, education, job, joint date, zip code, country, but also we have transaction related feature for each purchase. We have transaction amount, we have transaction timestamp, is the customer present on the point of sale or not, the currency, is the currency euros or dollars. And when we look at the transactional model into the relational database, it is usually modeled as a hierarchical parent-child one-to-many structure. We can see on the left we have customer with all of his or she's basic attributes related to her age, gender, etc., etc. We have the card. One customer can have many cards, and we have one on many transaction bound to that card. So if we start building machine learning model based on the transaction information only, like transaction amount and transaction date, time, customer present, currency, etc., we have not that powerful attribute set. Can we do more? Yes, because there is more information we can embed and enrich each particular transaction. And how can we create these additional features? Through aggregating transaction information, like average transaction amount for particular card, average time between subsequent transaction for particular card, average transaction hour for each transaction or purchase. So the question is how we can do that. If we start manually and try to generate all of these additional features per transaction, it is a very tedious process, and that is definitely not the way to go. But fortunately, a couple of years ago, something called automatic feature engineering or deep feature synthesis has been invented. And on this table below, we can see how it works. On the left side, we have basic transaction attributes. I am naming those attributes like A, B, C, D, and that is what we have from the system. But we can enrich each transaction with the mean value of the attribute A, standard deviation of that attribute, the mean of attribute B, standard deviation of attribute B, the mode of attribute C. If we say that attribute B is timestamp, transaction timestamp, that we can extract the hour and the weekday for that transaction. At the end of this process, using automatic feature engineering, we have enriched transaction. And according to experiments, these enriched transaction data brings to much successful fraud detection machine learning model. Is there any open source tool that can help us do this automatic feature engineering? Yes, there is. From the same authors that developed this deep features synthesis algorithm. We have the feature tools, which is open source, and generating additional transaction attributes like card mean, standard deviation, and average time between successful transactions is as easy to accomplish as the presented Python snippet. It is that simple. After that, we have enriched transactions. And once we have enriched the transaction set, we can easily apply classification algorithms like the aforementioned XGBoost on random forest that will help us find if some transaction is fraudulent or not. And if we apply the whole architecture and implement something in production, basically with each new transaction, our system will push that transaction into streaming service like Kafka or AWS Kinesis. We will evaluate them against the machine learning model we developed using feature tools and detect if the transaction is fraudulent or not and raise alert in real time if needed. So this is very powerful mechanism to reduce the costs from fraudulent transactions, which is not that trivial and naive based on the statistics. Another thing is fraud risk detection. My idea here is to present database storage, which is not relational, but can solve many, many problems today, like fraud rings detection. What are fraud rings? The definition is in the first line of this presentation. Basically, it is a group of two or more people that share common legitimate content information like phone addresses, social security numbers. So basically, if we have a couple of valid phones, addresses, and social security numbers, we will create synthetic identities using combinations of those. So if we have 3 phones, 3 addresses, 3 social numbers, we can have 27 combinations for synthetic identities. And these synthetic identities, the participants in these fraud rings, at the beginning behave very normally. Their normal behavior will lead to unsecured credit lines, personal loans, etc., which are not checked because the amounts are very small, and at the end of the day, these are normal bank customers. But after a while, for example, several months, the ring members will coordinate the activities and say, okay, we are going to maximize of our credit lines and loans and disappear. And after that, they're nobody, they're ghosts with their money taken from their bank accounts. So the fraud rings are based on some kind of relationships. We said that fraud ring consists of participants and members that share some attribute like address or phone. If we are going to solve this problem with a traditional database, we won't be that successful because we will have to deal with relational joins. After that, again, join. And after 3 or 4 joins, it will be very unsuccessful. So the question is, can we do better? Can we deal with database created just for that purpose? And yes, the answer for this kind of problems is Neo4j, which is a graph database, which is created to find this relationship with effective transitive walk of the graph, visualize the graphs and detect some properties of the graphs. There is a well-known Neo4j use case for fraud detection. I have a link on this presentation. I believe you will watch, probably, if you want, you will watch this video presentation and webinar. And you can find these URLs and see the content firsthand. So what we have here, we have 4 bank customers, John, Jane, and Matt, and we can see Matt shares social security number with Jane, Jane shares with John phone number, and John, Jane, and Matt share their address. So there is an efficient way to find if they share. The clusters defined from these users based on the shared attributes. Neo4j can be queried with a query language called Cypher. It is similar to SQL, and all developers that know SQL will find them comfortable with the Cypher language. And the results of executing this Cypher language block is detecting 3 rings, like Matt, Jane, and John sharing address, Matt and Jane share social security number, and Jane and John sharing phone number, as well as the financial risk connected if that ring disappears. But we can go a step further because we can look with Neo4j with transitive relationships. For example, Matt and Jane share social security number, but even if Jane does not share the street number with Matt, John is still suspicious because Jane is suspicious, but John shares something suspicious, which is a phone number with Jane. So we can apply very powerful Neo4j graph algorithms like the connected component algorithm. And on this graph, we can see we have 2 connected components. And again, executing the following Cypher query, we'll find 2 clusters, 2 connected components. The first is Alice and Bob, because they share something, and they share some transitive relationship attributes, but also John, Jane, and Matt, which are detected as connected component with financial risk containing all their loans and credit lines. So this is the total financial risk for the whole fraud ring. So very powerful mechanism, and I would say the same mechanism could be applied for detecting rings for COVID-19 and interactions between the people, among the people. Another thing when dealing with data is real-time detection of events using stream services like Amazon Kinesis and Kafka. With these streaming engines, we have a so-called continuous query execution. It is very much like ordinary SQL, but it is continuously running and evaluating in particular windows periods if we have some correlation. So what we have here, let's say we have automatic teller machines located in several places in the world. So we have the first location, which is blue, and the orange is location B. Even if we have blue ATM events on the time axis, which are closely related on the time axis, they're not suspicious. Same for the orange event. But if we have orange and blue events intermixed, that means we have very large distance between two locations, but we can see we have money withdraw from those locations, and that is not normal. So in Apache Kafka, we can implement that continuous query because Kafka supports windowing and also geodistance calculation. So if we detect something that is very far in distance, but very close on the time axis, that certainly is suspicious event, and we can react accordingly with some alerting and notifications. And at the end, we are witnessing great expansions of the deep learning algorithms and products that deal with text, images, voice, languages, language translation, image recognitions, etc., etc. This is a commodity today. So we have a lot of AWS, Azure, cognitive services offering this kind of abstraction layer around machine learning. So it is interesting to create brand new products with combination. For example, my exotic example is the tech customer sentiment from the call center audio records. So at the beginning, we have audio call. With Amazon Transcribe, we can convert the audio to text. I'm assuming here Dutch. Our first presentation was for the Dutch market, so this is why we have Dutch here. So after that, we have Dutch. But with Amazon Translate, we can convert Dutch into English. And finally, Amazon Comprehend that does not support in Dutch will do sentiment analysis against English version of the sentence. And finally, we can analyze and count negative sentiments. If we have a lot of negative sentiments, we can arise alert again. And while we were talking about this use case with combination of AWS deep learning products, in the meantime, in the AWS Connect, which is cloud software as a service call center offering from Amazon, we have something called Connect Contact Lens. And all of this we are talking about, like some custom implementation we have out of the box provided in AWS Connect. It is still in beta version, but it will be available sooner or later. So in the interest of time, I will summarize very quick. The first thing we must be aware when dealing with data is to define our business goals. Without defining our business goals, and if we know what do we want to achieve, there is no point all of these data transformations and the effort to give some meaning of the data. We must know, do we have some security compliance requirements against that data and the data we own, like GDPR requirements, payment card industry PCI requirements, and do we own some risks, and do we have some responsibility regarding that data? We must be aware where that data has been scattered across the enterprise and create data catalogs. We must monitor that the access to that data. We said information is everything today. It is a weapon and must take care about that data. We must normalize the data and transfer into some final destination like data lake and data warehouse for further business intelligence and machine learning tasks. We must sometimes pick the best tools for analyzing data, like graph databases. And this is very important that the relational databases are not the center of universe anymore. They are better tools for particular problems. So let's choose appropriate tools for solving those problems. Again, if we want to react in real time, we must stream our data towards some streaming engines like Kafka and AWS Kinesis, which are capable to query that data continuously and provide some alerts and notifications if needed. Find the hidden patterns in your data using machine learning. We said we can provide classifications, product recommendations, and all sort of machine learning algorithms against that data. And finally, we have a lot of products for deep learning based tasks and machine learning based tasks, which can be combined. We have commodity today to choose from our cloud providers like AWS, Azure, and Google Cloud. Just combine those products and create interesting brand new products that will bring some new value to our clients and to the companies involved with this data investigation. And finally, I will close my presentation that data management, mining and analysis is not a project that will end. We will start it, we will create implementation, test it, and after that it will be finished. Not, it is a continuous process with a lot of innovation. So thank you for your patience. That's all for me for this presentation.
Thank you, Marjan, for your excellent presentation. Last but not least is our colleague Cvetanka Eftimoska, and she will walk you through machine learning in Python. She is part of our data management practice as a senior consultant, and her specialties include relational and NoSQL databases, design and development, big data, ETL, data warehousing, Python, and so on. Go on, Cvetanka.
Thank you, Renata. So as Renata mentioned, I'm part of the data management practice. As part of this practice, our goal is to increase the data efficiency. We are focused on extracting and analyzing the most important and valuable information that are contained in the data. So as part of this, we are focused on machine learning and how we can use these algorithms on a daily basis to improve the process of analysis and extracting the information, and provide great value for the projects that we are working on and for our clients as well. That's why today I'm going to speak about machine learning in Python with a focus on the data preprocessing techniques. So first of all, I will define machine learning, which are the types of machine learning. I will explain the flow of the machine learning. As the first step will be exploration of the data set. Next, we will see the data preprocessing techniques, how we can build and test the model, and how we can extract the model statistics. First of all, I would like to give a small introduction into machine learning. Machine learning is a method of data analysis that automates the analytical model building. Using algorithms that iteratively learn from the data, machine learning allows computers to find hidden insights without being explicitly where to look. It is widely used in all domains for finding hidden information in the data. It is seen as a subset of artificial intelligence, and machine learning models build a mathematical model based on a sample data known as trained data in order to make predictions. And based on that predictions, we can use different data and the same machine learning model. So early classifications of machine learning approaches divided them into three broad categories. The first category is supervised machine learning algorithm. These algorithms build a mathematical model based on a data set that contains inputs and known output. Unsupervised machine learning algorithms take a set of data that contain only input and find structure in the data, like grouping and clustering of data points. And reinforcement learning is a computer program that interacts with a dynamic environment in which it must perform a certain goal, like driving a vehicle or playing a game against an opponent. The process of machine learning is composed of several steps. First of all, we need to prepare our data. Here we are going to apply some data preprocessing techniques. The next step is training and testing our model. And the last step is running model consumptions and extracting the model statistics. The libraries that I'm going to use are Pandas. Pandas is a package that provides fast, flexible, and expressive data structures. Scikit-learn is a package that provides many unsupervised and supervised learning algorithms. StatsModel is a package that allows users to explore data, estimate statistical models, and perform statistical tests. Matplotlib is a library for plotting, and Seaborn is a library for making statistical graphics in Python. The first step is exploring our dataset. If we want to see the descriptive statistics of the dataset, we are going to use the method describe with the parameter include equals to all. This means that we want to see the descriptive statistics of all the columns that are contained in our dataset. We can see the count of the values, the unique values, the mean value, and so on. Our main goal will be to find the clients that have deposit and those that don't have. The next step is data preprocessing. Data preprocessing is a crucial step in machine learning. Data preprocessing allows us to transform the raw data into a clean and usable data set. Data sometimes contains noise, missing values, sometimes it is in unusable format. And with applying these techniques, we will get a clean data and usable data that can be used for building a machine learning model. The first technique is handling missing values. First, we need to check if our data set contains missing values. This can be done by using the function isNull, and with summing all the null values, we can see in which column we have missing values. In our example, we can see that there are missing values in the column age, balance, and contact. The first thing that we can do is eliminating the missing values. The first way of elimination is eliminating rows with missing values. This means that if we have less than 5% of the data that is missing, we can remove the whole columns. In Python, this can be done by using the function drop_na and giving the column name as an input in the function. After this, if we check for missing values, we can see that now in the column age, there are no missing values, and there are only missing values in balance and contact. The second way is eliminating columns with missing values. If the column has 99 or more percentage of the data that is missing, we can eliminate the whole row because the estimation cannot be trusted because it is made from the 5% or less of the data. We will eliminate, in our example, we will eliminate the column contact just to see how this can be done. By using the function drop, and as an input parameter, we will give the column name. After this, we can see that only in the column balance we have missing values, and the contact column is totally removed. The third way of handling missing values is by estimating them. This can be done in two ways. The first way is by using simple imputer and filling the missing values with the mean, median, or the most frequent value. And the second way is by using the iterative imputer, which models each feature as a function of the other features. In this example, I used the simple imputer and the strategy mean. This means that all the missing values will be filled with the mean value of that feature. After this, we can see that there are no missing values in our data, and we can continue with the other technique. The other technique is dealing with outliers. Outliers are observations that lie on abnormal distance from other observations in the data. If we are working with regression, this is a very important topic. If we plot the distribution of the feature, we are expecting for an optimal result, we are expecting a normal distribution. And the common rule is that 68% of the data is distributed in the interval from mean minus standard deviation and mean plus standard deviation. 95% of the data is distributed in the interval of mean minus 2 standard deviations, mean plus 2 standard deviation, and 99.7% of the data is distributed in the interval of mean minus 3 standard deviations and mean plus 3 standard deviation. Everything that is out of the third interval are considered as outliers. So in Python, we will plot the distribution of the column balance, and we can see that this is not a normal distribution. After we will compute the first and the last quantile of our data, and we will remove the outliers. We can see also that the maximum value is far away from the mean value. After removing the values, the outliers, we can see that the distribution is still not normal, but it is acceptably closer, and the maximum value is not so far away from the mean value. So now we can apply this technique with the other features in our data set. The next technique is multicollinearity. Multicollinearity exists whenever an independent variable is highly correlated with one or more of the other independent variable in a multiple regression equation. Multicollinearity is a problem because it undermines the statistical significance of an independent variable. Using scikit-learn, we cannot straightforward determine if multicollinearity exists. So we will use the package stats model. One of the best ways to check for multicollinearity is by using the variance inflation factor. Variance inflation factor gives us a measure which estimates how much larger the square root of an the standard error of an estimate is compared to a situation when there was no multicollinearity at all. The numerical value of the variance inflation factor tells us what percentage the variance is inflated for each coefficient. For example, if we have a value of 1.9, this tells us that the variance of a particular coefficient is 90% bigger than what we would expect if there was no multicollinearity. When variance inflation factor is equal to 1, we can say that there is no multicollinearity at all. We cannot find a strict definition of what values of multicollinearity are acceptable, but in some resources we can see that values below 10 are acceptable, or values below 6, but I can say that values between 1 and 5 are considered as perfectly okay. In our dataset, we will use stats model to see if there is multicollinearity. We can see that all of the values are nearly 1, and we can say that there is no multicollinearity. If multicollinearity existed, we can remove the whole column, and that way we will avoid this issue. The next technique is how we can deal with categorical features. Dummy coding is a commonly used method for converting a categorical input variable into a continuous one. This means that we will create a duplicate value which represents one level of a categorical variable. Presence of a level is represented by 1, and absence is represented by 0. For every level present, one dummy variable will be created. In Python, we can use the method getDummies, and this way we will get a new data frame that contains one hot encoded columns. The next technique is balancing the dataset. Unbalanced dataset means that the target variable has more observations in one specific class than the other. If the difference is very high, we can say that our dataset is unbalanced. And balanced dataset means that positive values are approximately same as negative ones. On the picture below, we can see a simple example of unbalanced and balanced dataset. There are multiple ways, multiple approaches for balancing the datasets. I will explain only 2 of them. These 2 are the simplest one. The first one is oversampling or upsampling. This means that we will extend our minority to be the same size as the majority. So the advantages of this approach is that there will be no loss of information, but the disadvantage is that we might have overfitting. The next approach is undersampling or downsampling. This means that we can cut our majority to be the same size as our minority. Here we can, the advantages are that the runtime can improve and it helps in solving the problems. But the disadvantage is that we might lose some critical information. In this example, is shown how we can do this in Python. On this dataset, undersampling is the dataset is balanced by using the undersampling approach. Because I wanted to avoid the overfitting, I cannot say that this is the best. Maybe there is, for sure, there are better ways of balancing the dataset. This is done in one for cycle, and all of the values that can be removed are removed from the majority. The next technique is standardization. We can say that all of our features are not on the same scale. So our model will give more weightage to the ones that have bigger values, but this is not an ideal scenario because the other columns are important for building the model. So to avoid this issue, we will standardize the values. I just want to mention that in some examples, the standardization might not give better results. The results can be even worse. In Python, we can use the standard scaler, and also the idea behind all of this is that we can transform the data such that its distribution will have a mean value equal to 0 and standard deviation equal to 1. The next technique is shuffling the data. Shuffle algorithms randomly shuffle data from a data set within a column or a set of columns. By shuffling the data, we ensure that each data point creates an independent change on the model without being biased by the same points before them. So we will shuffle our inputs and our targets. And after this, as the last step, we will split our data into training and test set. The training set contains a known output, and the model learns on this data in order to be generalized to other data later on. And the test data set is used to test our model and how it will perform. We will use the method test train split, train test split, and the test size will be 0.2, which means that 80% of the data will be for training and 20% of the data will be for testing. We can split the data 80-20 or 70-30, whatever is more suitable for the example. The next step is building a machine learning model, because now we are going to find the clients that have deposit and those that don't have. We are going to use a logistic regression. Logistic regression is used to model the probability of a certain class or event existing, such as pass fail, alive death, win loss, and so on. In machine learning, logistic regression is defined as a supervised machine learning classification algorithm used to predict the probability of a target variable. The nature of the target variable is dichotomous, which means there would be only two possible classes. So the dependent variable is binary in nature, having data coded as either 0 stands for yes or success, 1 stands for success or yes, and 0 which stands for failure or no. In Python, for training the model, we can use logistic regression from scikit-learn. We will fit our training set and our training set, our inputs and our outputs. And for testing, we will use only the test inputs. The accuracy of the model I will show on the next slide. So this way we can say that our model is trained and tested. The last step is building confusion matrix and computing precision, recall, and depth measure. Confusion matrix is used to see how many of the values are correctly classified and how many of them are misclassified. In our example, we can see this on our test set. Also, I'm using the confusion matrix from scikit-learn. And also, very important are the precision, the recall, and the F measure. Precision quantifies the number of positive class predictions that actually belong to this class. And recall quantifies the number of positive class predictions made out of all positive examples in the dataset. F measure provides a single score that balances both the concerns of precision and the recall in only one measure. And the F1 score tries to make this into account, giving more weight to false negatives and false positive values, while not letting large number of true negative influence the score. So in the picture on the right side, we can see that the accuracy of our model was around 83%. This means that 83% of the data was correctly classified, and 70% of the data is misclassified. We can try to apply some different data preprocessing techniques or use feature engineering to find which of the features are the most important for building the model, and exclude those that don't give that are not very important, and maybe we can have even better results. As a conclusion, I would like to say that machine learning denotes a step forward in how computers can learn and make predictions. It has applications in various sectors and is being extensively used everywhere. Applying machine learning and analytics more widely lets us respond more quickly to dynamic situations and get greater value from our fast-growing troves of data. Machine learning has been gaining popularity since it came into the picture, and it won't stop anytime soon. Thank you for your attention. If you have any questions, feel free to pose them.
Thank you, Cvetanka. Thank you, everyone. So now we're open for questions. Let's see. We have 3 questions so far. The first question is for Aleksandra Stojanovska. Whether UiPath can be integrated with other CI/CD tools?
UiPath actually has his own orchestrator. That is a server-based application that lets you orchestrate with your robots. It runs on a server and connects to all the robots within the network. It has a browser-based interface that enables you easy manage with your robots simply with a click. Basically, the orchestrator lets you to manage the creation, monitoring, and deployment of the resources in your environment. And it's acting the same way as integration with other third-party applications. And regarding other CI/CD tools, I've heard that there is some Jenkins plugin for UiPath, but I haven't tried it yet.
Thank you. We have another question for you. Why did you choose UiPath over all other RPI tools?
UiPath is extremely user-friendly. It has free community edition, and it's allowing everyone to download it. It's easy to learn, has a lot of learning materials and videos online. As well, there is a great support on the UiPath forum.
Thank you. And another one for you. Do you think that RPI will be the future from the testing perspective?
At their core, RPA and testing automation might look similar because they both rely on automation. But however, I think that there are differences. test automation needs to be applied to a product. It has to be implemented in different environments, and it's also limited to a set of users. And robotic process automation, on the other hand, can be applied to business processes and products. It only needs one single environment, production environment, and can be used by all individuals within a team. So robotic process automation can be considered as a testing tool, but I must specify that it's mostly business process automation oriented. Maybe it has reached the next level when you don't really need to rely on other systems to make things work the way you want. But the reports are telling that it's still not good as test automation tools for testing aspect.
Thank you. So if you have any other questions, feel free to ask them on our questions and answer tab, or maybe raise your hand. I have a question for Marjan. Do you think digital transformation is all over the world a lot and maybe too emphasized?
Before the crisis or after the crisis?
Even more now.
Yes, the digital transformation has been started, I would say, a couple of years ago with some greater extent, but I think not all of the companies took this process very seriously, because they know that have data, but they're just accumulating that data. They are not mining that data in order to find some patterns. If they can mine some customer behavior, predict something for their customers, etc., etc. Who knows? So maybe because of lack of resources that will implement that, maybe because of the lack of vision. But after the crisis, I think with the strengthening of the e-commerce approach and the strengthening of the online services, sooner or later, all these companies will have to understand their data and use that data in order to make those online services better. So if you have e-commerce site, it is normal to assume and to wish to have product recommendations on that e-commerce site. It is not today e-commerce site if you can create product recommendations. But also, once we have online services all over the world, and if most of the companies run their businesses and their business lines online, there is a very there is opportunity for fraudulent transactions. So they must protect their businesses from some unusual customer and client behavior. They must detect in real time if we have some fraudulent transactions or not, because once we go digital and online, it is not the same ecosystem and face-to-face interaction where you can see the customer. So from all of these aspects, making your business better and securing your business, understanding your data, protecting your data, and create value from that data is very important for all of these companies all around the world from this point further.
Thank you. We have a question for Cvetanka and Marjan as well. Which or how many different cases have resolved by far using machine learning?
Okay. This is a concrete question about us as Interworks.
I am assuming.
Or what can be resolved,
yes,
because
yes.
if this is global
No,
case.
for Interworks.
Yes, for Interworks, I would say we are playing and implementing internally various products based on machine learning and cognitive services that deal with sentiment analysis, image recognition, etc., etc. So I would say yes. I would say the author of the algorithms like product recommendations based on alternating least squares or factor of matrix factorization is commodity today. So yes, we are dealing with these algorithms today. And most importantly, as I said in my presentation, we have commodity to use these services in the cloud. Azure or AWS or Google allow us to apply sentiment analysis with a single line of code and one API call. We will just provide the text and we will get that sentiment analysis. If we say today that we are dealing with data science, we are not necessarily dealing with standard scholars, means and standardization. These are all wrap services and exist online as commercial services. So most importantly, here is the vision. How can I use, how can make this data help my business grow? How can my products make better in the eyes of my customers? So yes, it is commodity and we are using it.
Cvetanka, what do you have to say about this?
I think that Marjan gave enough explanation.
Okay,
Yes. Okay.
Thank you. If any other questions? I have a question for Petar. Do you think that machine learning in SnapLogic is the future?
So definitely from what we can see in SnapLogic in the next few years, they are following the trends on this topic, and they're in each release they're updating the snaps, and there are some new features that are adding to the platform. So I believe that SnapLogic is a powerful tool as an integration, but will become same as machine learning and data science tool, because it is really quick to create something that can be useful in data science.
Thank you. I don't see any other questions so far. Well, would you like to say some closing lines, all of you?
No, let's wait a little bit. I would like to hear some questions. You can ask some details if you are interested for. So.
Let's wait. In the meantime, I will ask Cvetanka one question. How important has data management proved to be in these uncertain times we're facing, especially companies? We know all of them are facing a lot of problems and challenges during the pandemics. So how important is data management during these challenging times?
So I can say that the companies collect the data, but it's not on the central place. And now it is very important. For example, let's take, for example, the data for COVID-19. If we have everything on a central place, we can have a lot of reports. We can make predictions based on that data, and so on. So here, that's why data management is so important. We have to know how to deal with the data and how we can extract the most important features from that data, and so on.
Have you made some reports or research for the pandemics?
Yes. Yes.
Okay, thank you.
Okay, Renata, if we don't have...
we don't have, I see on Facebook, we don't have any questions as well.
Words.
Well, I think we can have our closing words, so go ahead.
Starting with me, or we will go the same with the same order. Okay, I will start first. This is a little bit similar to my summary in my presentation. I would just say, understand your data, be aware what do you own, what are the problems and the opportunities, execute your SWOT analysis. And once as a business, you know what are you trying to achieve, use your data at maximum. There are a lot of tools today capable to solve many problems. Pause, think about the problem, choose the right tool, create the right team, or engage some third party that will help you implement your business processes. And after that, measure your success. I believe your KPIs will drastically improve.
Thank you. Oh, sorry, we have another question, Marjan, for you.
Okay.
You said that the most used model is XGBoost, but it is also known for most overfitting problems. What's your opinion about this?
Yes, that depends on your data and the quality of your data. What I said about the XGBoost is a fact. It is a fact that on the latest Kaggle competitions, XGBoost outperforms most of the other algorithms. But as usual, we should not take for granted any algorithm, and we must cross-validate that algorithm against our data. So I never take for granted anything, and I just mentioned some facts that if I don't know which algorithm should I start with, I can try with XGBoost. That is a fact. But certainly, as Petar Rajchinoski presented us in his presentation, that SnapLogic will execute cross-validation of the algorithms and decide, okay, for this problem, logistic regression is your best algorithm you can apply. So really, data science and machine learning, especially when you are trying to normalize and reach your data by yourself, it is something, a kind of investigation. You must try several things. So let's say, yes, we can have some overfitting problems with XGBoost because it is really good. That's why it is overfitting. But also, we can try logistic regression. We can try with random forest. We can try with some fast-forward deep learning network, etc., etc. So it is up to us to check and validate. Trust, but validate. It is Russian proverb.
True. Thank you. Aleksandra, your closing words?
Well, as I said, automation is going to be the future of the business industries, so RPA cannot be ignored and its application must be considered in many different industries.
Thank you. Cvetanka?
So I can say that the future is artificial intelligence, machine learning, and deep learning. And for sure, it's very important to know the concepts of machine learning firstly, and then choose how we can apply and which model we should use.
Thank you. Petar?
And I would say that for those that are willing to learn something new and expand their knowledge in the machine learning field and have the some understanding of what SnapLogic is, I would like to encourage them to go ahead and try SnapLogic machine learning, and it will open a new window for them. So that will be my closing word.
Thank you. Thank you, everyone. Thank you, everyone, for attending our webinar. And we here invite you to our next webinar, which is tomorrow, about boosting customer acquisition using cold data. Till then, stay safe. Bye.
And spread the word.
Yes, that too.
Bye.
Bye, everyone.
Bye.
Bye.